Hi and welcome today to this demonstration of my project titled Empirical Analysis of Closest Pair of Points Algorithms. In this project, I compare the performance of two fundamental algorithms to solve the closest pair of points problem. The first one is brute force algorithm with time complexity of n square and the more optimized divide and conquer algorithms with time complexity of n log n. We'll use randomly generated points to empirically test their runtime performance and verify how theory aligns with the practice. Before DB diving into the algorithms, I have included a simple input validation system that checks user eligibility for an APK benefit. And here's the code for that. We are entering the year of the birth, one property S, amount 30,000. Yes. If based on the response, we assign the amount API amount 100. If they own multiple properties, or if zero, if not, the small logic blocks mimic real-world pre-checks that might run before launching heavy computations like this. Now we move to the core project, the closest pair of points problem. I have different helper functions like equity distance and then coded two approaches. Brute force, which compares every possible pair, and the divide and conquer, which recursively divides the problem and intelligently limits comparison. The goal is to see how both approaches perform on the exact same datasets. Now, divide and conquer sorts the input first, uses the state checking strategy, and near the midpoint to final optimal solution more effectively. And we're running the demo cell here. Now we explore the demo. It first generates 10,000 unique random 2D points. We run both algorithms three times to average the performance and reduce any randomness from fluctuations in CPU usage or system load. We are generating the iterations, first iteration is done, second iteration is coming. We're running multiple iterations, like it will be two or three, and you're waiting for the second iteration is done, the third iteration is coming. The three iterations are done. The average time for the brute force is 19.4361 seconds, and for divide and conquer 0.890009 seconds. And finally, we started with the basic input validation script, then explore two algorithm approaches to the closest pair problem, and finally compare the performance of the real data uploaded here. Results clearly demonstrate the practical importance of using efficient algorithms for large data sets. Thanks for watching.